Oh, you know what I realized? Because somebody came in for help this morning. Apparently not any of you. But somebody came in for help this morning and they said, hey, Mr. Park, didn't have any of the problems where you got to solve for the unknown integral.
Yeah.
And I remembered why, because we always did it before, but last year, remember I told you about last year's class? How terrible they were? I just got so disgusted at them, that I just took out all of those problems. So I didn't change the assignment sheet, so that's why you didn't get any problems where you had to solve for the unknown integral.
Wait, but do we need to know that for like the test?
No, were you here yesterday?
Oh no, I know we don't have to know for the 18th, but we don't need to know.
No.
Oh, really?
Yeah, so don't worry about it.
But can we still go over cosine?
Yeah, we're gonna still go. Why cosine to the 6?
Because you said that's a bonus, but you didn't work it through.
But he said
But then I also say I'm tired, I'm not gonna give you bonus anymore. After the last debacle.
He said fair game.
Did he? Yeah, because I wrote it down.
Okay, let's just do what we're supposed to do here. 25. 25, integral, gosh, I can't even read this. 0 to pi over 2, x squared, sine 2x dx. So now that we're not going to be doing any problems solving for the unknown integral, then this makes it really easy for you. So all you got to do is ask yourself, can I do tabular or do I have to just do regular integration by parts?
Tabular.
This one you can do tabular. So, because this is a polynomial, you can take the derivative down to 0, and this one here, can you repeatedly integrate it? Yeah. You bet you can. So, keep on taking derivatives until you hit 0. This column, you keep on taking antiderivatives till you get there. So is it just negative cosine 2x?
No, because you left the space.
See? Okay. Is this one just negative sine 2x?
No. For the 1/4.
And is this one just cosine 2x?
Yes.
No. And then like Jaime Escalante said, tic-tac-toe. Plus, minus, plus. Now you can write down the antiderivative. This times positive 1. Negative 1/2 x squared cosine 2x. And then the next term is going to be this times negative 1. So plus 1/2 x sine 2x. Am I doing this correctly?
Yeah.
Of course, I'm the teacher. And then the last term is this times positive 1. Plus 1/4 cosine 2x. Now, do I need to put the plus c?
No.
No, because this is a definite integral. The c's are going to cancel out, so you go 0 to pi over 2. So now, plug in the top number. What happens when I plug in pi over 2 here? Cosine of 2 times pi over 2, that's cosine of pi. Cosine of pi is negative 1 times pi squared over 8. Negative pi squared over 8? Is that right?
Yeah. Positive. No, positive.
Positive.
So negative 1 and
Yeah, because a negative times a negative equals a positive. Say it.
negative times a negative equals positive.
And then if I plug in pi over 2 here, you get 0. If I plug in pi over 2 there, you get negative 1/4. Now plug in the bottom number. 0 plus 0 plus 1/4. Is that where you guys slipped up? So many times students think if you plug in 0, guaranteed it'll be 0, but right there, it's not, because cosine of 0 is 1. So what's your final answer going to be? Pi squared over 8. What's negative 1/4 and negative 1/4? Negative 1/2. Box that, that's the answer.
Always let you use mint.
They want you to use your calculator to verify, but we're Iolani, we don't need to do that.
Oh.
Look, in this class, you either use your calculator or you do it without a calculator. You don't do both.
Oh.
Remember I told you guys in the beginning, don't follow the directions because they're crazy? I'm pretty sure I told you that. Get 31. 31. dy dx. Okay, they're using theta, but like I told you, I'm not going to use theta. X is greater than 1. Why do you think they give you this condition right here?
Because it's an
Absolute value.
Because of the absolute value, right? So you don't have to worry about it. So, if you are given the derivative, how do you find the original function? Yeah, you integrate. So what's the difference between this problem and this problem here? What's the difference? No difference. No difference. You know what that means? French? No difference. Hey, you guys pretty. So can I do tabular on this one? No, this one cannot do tabular. So you just have to do regular integration by parts. So you gotta make the chart. Alright? Did you guys do that?
Yes.
So which one do I put here? Do I put the x here or the secant inverse?
Inverse.
See, you guys know what you're doing. What's the problem? Okay, now you gotta take the derivative. Do you guys even remember the derivative?
1 over x.
Absolute value of x, but because of this condition, you don't need absolute value, right? Square root of x squared minus 1, and don't forget the dx, because that would be a minus 1. And then over here, you gotta do antiderivative, so 1/2 x squared. Plus c, but again, I told you we're gonna put the plus c at the end. So, the integral of u dv, which is the thing we're trying to find, is equal to uv 1/2 x squared secant inverse x minus the integral of v du. Now what happens when you multiply this times this? You get 1/2, which you can throw on the outside. This x cancels into one of those x's, and you get this. So doing this problem hinges on whether you can do this integral right there. And how do I do that one?
Sub.
See? What's the problem? U equal x squared minus 1, du equal 2x dx. So this integral becomes radical u on the bottom, right? What do I substitute for the x dx? Right down yonder. 1/2 du. So that comes out to 1/2. Now this is the same thing as u to the negative half, right? So you gotta make the power 1 bigger. U to the half, put the reciprocal in the front, cancel. Plus c. Okay, so let's write down the answer. Final answer, survey says 1/2 x squared secant inverse x minus 1/2 times that. So minus 1/2 u to the 1/2, but you gotta resubstitute back in. What was u? So square root of x squared minus 1, put the plus c because you don't want to get an additional minus 1, yeah? Box that, that's the answer. Yeah. It is. It is the answer. What was so hard about that one? I know what was hard. You guys couldn't remember the derivative of secant inverse.
No, the theta.
But I told you guys.
The theta made it hard.
And so what did I tell you? If you don't like the theta, change it to x. And why do they put theta in the book? To prepare you for polar coordinates. But we're AB, we're not going to see it. But when you go to college next year, then you're going to be doing derivatives and integrals of polar trig functions. I already told you, right, what you're going to do. Remember these graphs from polar? Remember the limousin with the inner loop? So next year, when you take second semester calculus, you're going to compute like the area of that inner loop part right there. Or right at this point, what is the slope of the tangent line? That's exactly what you're going to be doing. I'm not going to take any more math, Mr. Park. I'm going to show you. Where is 43? Aha! How many people got it?
No.
One person.
I need
Tom?
No. Sorry.
Now, didn't they give you a hint in this problem?
No.
Okay, let me read the directions. In exercises 43 to 46, evaluate the integral by using a substitution prior to integration by parts. So they did give you a hint.
What does that mean?
So good.
That means do a u substitution before you do integration by parts.
What?
Okay, now, I admit, this is the first time, this is like an extension. But on the test, you're gonna see one of these here. And it's not gonna be a bonus. Okay, so they're giving you a hint. Do I have to give you a hint on the test? Hint, do a u substitution first.
Yes.
Okay, maybe I'll consider it. So, what should I do? U equals,
Yeah.
see? So have we memorized the derivative of this yet?
1/2,
I see.
yeah.
Okay, good. So, what do I substitute for that right there? sine u. But here's the hard part. What do I substitute for dx? Well, here's dx. What happens when I move this on this side? You get 2 root x du.
2 UD.
Mr. Park, how am I supposed to do an integral if it's du if there's an x here? Well, let me ask you this. What can I substitute for this root x? Right there, u. See how it's tricky?
What?
Look at your substitution. Root x is equal to u, so that's equal to u. So that means this integral, here, let me just write it in the proper order, like that. Look at that. Now can I do integration by parts? You're supposed to say yes. In fact, can I do tabular?
Yeah.
Yes. Height. Height means yes.
Japanese.
Yeah, and I'm not even Japanese. So now you can do tabular. 2u sine u. So this column, take the derivative till you hit 0.
2 0.
P.
0.
I don't know how you say 0 in Japanese.
Zero.
0.
0.
This one you do antiderivative.
Wait, can you take the U out or no?
No.
I mean
it's-
the two out.
Oh, if you want to take the 2 out, you can, but I'm choosing not to this time.
Okay.
Antiderivative.
Negative cosine u.
Again,
Negative sine u.
I think it's easier to just speak French. Encore. Encore.
Tic tac. Oh,
There's no
no. No
time.
toe. It's just tic tac.
Okay, so this times positive 1. Negative 2u cosine u. And then this times negative 1. Plus 2 sine u. And then don't forget the plus c. Box that. That's the answer. No, don't be ridiculous. You have to resubstitute back in. So your final answer is, you gotta substitute the root x for u. What happens if you don't? Minus 1. 99 is a darn good score on the test, right? Now, did I only assign 40? You mean didn't I assign number 45 as well?
No.
Really? See what happened last year? Yeah, let's say down for the test. Q3.
Are we better than last year?
I told you guys are way better.
Listen, last year was another.
Remember last year I told you that I taught 2 sections of AB. The number 1 student, Shay Stevens, his final average was 90.1. That was the top student in 2 classes.
And would it range down?
Normally that doesn't happen. Normally the top student is like 95, 96, 97, 98. What is that? I think in both classes there are only like 5 students that got A's for the year. That's all, that's it. Normally it's about half.
Senior.
No, I told you I had to give D's in the first quarter.
Not.
Yes. I'm not gonna mention any names. What problem are we doing here?
I was waiting for
Cute.
you.
So, Royce?
Garcia.
Royce, what's the last name?
He's in freak out. He's in freak out. He has
Hey, this thing is being videoed, you know.
Hey, he's not gonna watch it.
Okay, now if this is an integration by parts test, the first thing you ask yourself is, can I do tabular?
Yeah.
Yeah, this is so easy, my dog can do
I can
this.
rewatch this video just for fun.
Okay, so this column, take derivatives until you hit
1
0.
0.
Or,
Zero.
and then this one, antiderivative. And then tic-tac-toe. This times positive 1. This times negative 1. And then don't forget to put the plus c, but this is multiple choice, so you have to just pick out the answer. Do I need to do that too? Okay, I will. Shh. A. Hey, look, I could have. Look, they have sine inverse and tan inverse, look, 53 and 54. I could have just assigned that instead of just writing it up there, but whatever. Okay, so Monday, I'm not going to see you tomorrow, right? So Monday we have a quiz. The quiz is only going to be on 7.3 here. So, since you're not gonna have the solving for the unknown integral thing. Oh man, this quiz is easy.
Is there a practice?
So it's only
No,
tabular.
no, you don't need practice. This, if you just do the homework, it's fine.
Oh, no, never mind.
So okay, this is my guess. You're gonna have 5 problems. 3 of them is just regular integration by parts, and the other 2 will be, we can do tabular. That's my guess.
Oh, the U.
What's integration by parts? That's the integral of u dv is equal to uv minus the integral of v du. That's integration by parts.
Oh, okay.
Tabular is a shortcut for that, but it only works in certain situations, but I think you guys know which situations that they are.
Yeah.
Okay, do we really need to go? So,
Yeah.
but no.
Oh.
Okay.
Wait, can you just not put it on the?
No, I'm not. So now that you're not required to know solving for the unknown integral, I wish I knew that yesterday, we could have finished really early. Yeah. Okay, let's just say you're in an integral B then.
Yeah.
Northwestern, do they have integral B?
Yep.
See? It's not just MIT. It's at a lot of colleges. They have integral B's. Okay, so how do you do cosine to the 6x? I kind of hinted yesterday. It's like cosine squared cubed, right?
Yeah.
Okay, and what's the only way you can integrate cosine squared?
The 1/2.
You gotta go 1/2 plus 1/2 cosine 2x, correct?
Yeah.
But now you gotta cube it.
Oh,
Are we really gonna do, okay.
What's the reason why?
Okay, so let's recall what we learned in algebra 2. A plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. Who said minus? There's a plus sign there, they're all pluses. So, if you multiply this up, this is a, this is b. What is a cubed? 1a plus 3a squared b.
Whoa.
So 3 times this squared times that
3/4.
times that. 3/8 cosine 2x
Whoa.
plus the next one will be 3ab squared. So 3 times this squared.
Yikes.
3/8 cosine squared 2x. And then this is b, so you gotta go b cubed. Cube this whole thing. 1/8 cosine cubed 2x. I don't know why we're doing this. We're AB. We're not gonna ever have to do this unless we enter the integral B. Okay, you know how to
But
do
you're not
that?
gonna put it as a bonus?
No, not this one.
Okay, then. Okay, then we don't need it.
No.
I'm shocked that you two back there said that. Okay, you know how to do this and this, but what about this one? Well, what's the only way in the whole world to integrate cosine squared?
1/2.
You gotta replace it with the identity 1/2 plus 1/2 cosine
Oh my
4x. It's not difficult, it's just tedious. Now, this is the one right here. That's the one. How do you do that?
Integration by.
No.
Oh.
Okay, let's just do a simpler one over here. How would you integrate cosine cube? Okay, maybe this could be a bonus, but no, this is not a. Now that I'm thinking back to the homework assignments, I did assign this when we did U substitution. I'm pretty sure. You have, okay, you know what you do? You have to split this up into cosine squared times cosine. That's what you gotta do.
And then use the
And
identity.
yeah, what's the identity for cosine squared?
On 1 minus sin squared.
Yeah, just go 1 minus sine squared x. Use the Pythagorean identity. Now, if I gave you the problem like this, wouldn't this problem be easy?
Yeah.
What would you do then? U substitution. U equals. No, here's the. This is the hint right there.
Oh, codes.
Sine.
Sine.
Sine x.
Oh,
Because then du, what is the derivative of sine x? Cosine x. Yeah, see how that thing is there? So this just becomes 1 minus u squared du. That's on the list. U minus 1/3 u cubed plus c. Resubstitute back in. That's what that one is. And then just put all 4 of them together.
Whoa.
Okay,
Wait,
Like I said, we're AB. we're not gonna get. However, you take second semester in calculus next year in college, you might see.
on.
It just depends who your professor is. Maybe your professor might go on easy on you. Who knows? Can I erase this?
No.
Okay. Okay, Craig, let me put your mind at ease. Don't worry about this.
Okay.
Don't worry about this. This won't even be a bonus. You know how I know? Because there's no bonus anymore because of the debacle that occurred last time. You know, if I give a bonus problem, I expect you to actually like try it.
I
We
did
did
try
it.
it, and then I erased my work because
That's
of
not
that.
Yeah, that's the excuse to be this. Okay, today, so obviously we're spending 2 nights on 7.4, so I guess we're just doing the first half.
Sorry.
What? I don't really remember ever splitting this up into 2 assignments. I think this just happened last year because of how dumb they were. Oh, I shouldn't say dumb on a video, yeah? How stupid they were. Okay, now, the kinds of differential equations that you guys have to solve are this kind, like here. dy dx, okay, let's just do an easy one. Cosine 3x. Okay. If you're, again, you guys remember what a differential equation is? It's an equation with a derivative in it. Okay? So if you know the first derivative, how do you find the original function? You find the antiderivative. So is the antiderivative of cosine 3x just sine 3x?
No.
No, because I left the space for the 1/3. And then plus c. Right?
Yes.
And then sometimes they give you an initial condition to figure out the value of c. Okay, so we already know how to solve that kind of simple, that's the simplest of differential equations, but now we're going to kick it up a notch.
Oh.
What happens when you see a differential equation that looks like this? dy dx equals, okay, let me think of something good here. X squared y squared with initial condition y of 1 equal 2.
Whoa.
Now, what makes this differential equation different from this one?
There's 2 variables.
Yeah, because it's got x's and y's in it. See, like this one only has x's in it, so all you have to do is simply find the antiderivative. But when you have x's and y's in it, can you simply just find the antiderivative?
No.
No, you can't because of this y. So what are we going to do here? Did anybody read ahead? Usually there's like 1 or 2 people. Okay, so this is what you do. The book calls it, you separate the variables. In other words, you put all the y's on the left side of the equation with the dy, and you put all the x's on the right side of the equation with the dx. We call that separating the variables. So like this, dy over y squared equals x squared dx. Basically, you just do algebra 1. Put all the y's on the left, put all the x's on the right. In fact, they shouldn't call it separating the variables, they should call it segregating the variables.
Oh.
Segregate.
Okay, let's just call it separating the variables. Does everybody see what I did?
Yeah.
Yeah.
You sure?
Yes.
Okay, now, once you separate the variables, you got all the y's on the left and all the x's on the right. Now remember, to solve a differential equation, we want, like, what function do you take the derivative of to get this? So your goal is to get y equals something. What function do I take the derivative of to get this? So what you need to do is you need to solve for y, that's your goal. So, what do you think I should do here? Okay, I'll just tell you, you integrate both sides. Okay, what's the integral of the left side? Bailey, integral of the left side.
1 over y. Wait. Maybe
Close.
2 over y? I don't know.
Yes, you do.
Wait.
Okay, I'll give you a hint. Isn't this the same thing as y to the negative 2?
Yeah.
So you make the power 1 bigger, put the reciprocal
Oh,
in the front.
negative.
Okay, negative 1 over y. Is that correct? No?
Yeah.
Negative y to the negative 1? Almost correct.
Oh,
What happens when you find the antiderivative?
oh plus c.
Plus c.
Oh.
There's always a plus c when you, how come you put c1, Monsieur Park?
There's gonna be another one.
Yeah, because on that side you're going to have another one, that's right. Well, don't they cancel out? Well, how do you know this c is the same as that c? So no, they don't always cancel out, that's why I put c1. Now what about the right side? What is the integral of x squared? That one's easy.
1/3.
See, this is what puzzles me. How come you guys can do this when it's a whole number, but when you get a negative number, all hell breaks loose? I don't get that. Plus C2. This constant might not be the same as that constant. In fact, they're probably different, so that's why you have to write it. Now watch what I'm going to do. And this is not magic. Negative 1 over y is equal to 1/3 x cubed plus c.
No.
Because they're constants.
Exactly. If you have a constant and you subtract another constant, don't you simply just get a constant?
Oh, yeah.
A constant minus a constant equals a constant. A constant, see, you can do lots of things with constants. You add two constants together, you get a constant. You subtract them, you get a constant. What about multiplying? Constant. What about dividing them? Constant. No, that's what we do. So, you know what we do? We mush the two constants together into just one. No, and it doesn't matter if it's on the left or right, but normally we put it on the right. Now, is there a way to figure out what this value of c is?
Yeah.
Yes, you use the initial conditions. When x equals 1, y equals 2. So substitute. What happens if I substitute 2 for y there? You get negative half. What happens if I plug in 1 for x? 1/3 plus c. Solving for c, I get c equals, can you do that in your head? Negative 3/6 minus 2/6. Negative 5/6. Okay, so this is what we have so far. Negative 1 over y is equal to 1/3 x cubed minus 5/6. Box that, that's the answer.
No.
C.
No, we did this, we didn't put the plus c. We figured out what it is, no, so no. So box that, that's the answer.
No.
No, we need to, look, we need to find a function, we need to solve for y. What function do you take the derivative of to get that? So, I just told you what you had to do. You gotta solve for y. You wanna get into the form y equals something. So, how the heck do I solve for y in this equation? Here. How do I get rid of this minus sign? Multiply both sides by negative 1. So basically, you're just doing algebra 1. That's all you're doing. Multiply both sides by negative 1. And then, what do I do here? Reciprocatize both sides.
Oh.
So y equals, now there's two things you can do. Would you rather just go 1 over this thing? Or would you rather go this thing to the negative 1?
We can do that.
That's the same thing as 1 over, right?
Oh.
I don't care which one you do. I like, that looks prettier to me. And there you go. Now this, I gave you a simple example. Now we gotta kick it up a notch now. Okay, so let's go through the, what do you have to do? So when you see a differential equation with x's and y's in it, or just y's in it, the first thing you gotta do is separate the variables. Integrate both sides, mush the two c's together into one c, and figure out the value of c right then. Because you know what a mistake a lot of students do? They wait several steps and then they put the plus c. But you can't do that because it changes the function. See, like over here, you have negative 1 over y. What happens when you multiply both sides by negative 1 and then reciprocatize both sides? You can't decide at that moment, okay, now I'm going to put the plus c, because now it's a different function. So what you need to do is, as soon as you have the value of c here, you compute it right then. Do not wait until further steps. Okay, let's just do another one. We just got to keep doing this. That's why you got 10 problems tonight. So actually, tonight's homework is going to be pretty mechanical. Tomorrow night, then you got to start thinking. Okay, dy dx is equal to, okay, let me think of a good one. Let me think of a good one. 2xy with the initial condition y of 0 equals 3. Yeah, that's good. Okay, here we go. How do I start this? I see a differential equation, got x's and y's here, so what should I do? Separate the variables. So put all the y's on the left, put all the x's on the right. Can everybody do that? Now, you see this constant 2 here? It doesn't matter. You can have a 2 here, or you can put a 1/2 on this side. Constants don't matter. I'd rather look at a 2 than a 1/2, yeah? But it's up to you, it doesn't matter. Now what? What's the next step? Integrate both sides. Okay, well, left one. Hazam alam.
So that'd be natural. No. Wait,
Natural log absolute value of y plus c. Yeah, but Mr. Park, did you say we're going to mush the two c's together? Yeah, so you don't need to write it because you're going to mush it with the other one, remember? Mush. Okay, what's the antiderivative of this one? This one's easy. My dog can do this. X squared plus c. Mush the two c's together into one c. Okay, now here, I'm going to show you something. You don't need the absolute value now. Why not?
Because there's
Why not?
why.
Because of this, the initial condition. What is the y coordinate?
Positive.
Yeah, it's positive. If the inside is positive, you don't need the absolute value, so that's why you don't need it in this particular problem. However, what if the initial condition said y naught equal -3? Then you need it, that's right.
Can you just write that to be safe?
No, because you're gonna have to solve for y, not absolute value of y.
Oh.
Okay, so there you go. So what determines whether you put the absolute value or not is this, the initial condition. If the initial condition is positive, remember how absolute value works? If the inside is positive, you leave it alone. What if the inside was negative? Here, let me just show you this. What would happen if this was a -3? What would you do here? You negate it. Have we forgotten the absolute value?
No.
This is the difference between a 4 and 5 on the AP exam. If the inside is positive, you leave it alone. If the inside is negative, you negate it. That's how absolute value works. But this was my problem. So what should I do now? What am I going to do with this plus c?
I'm missing.
You find what it is by plugging in the initial conditions. So if I plug in 0 for x and 3 for y, what are you going to get? Natural log 3 is equal to 0 plus c. Hey, we just figured out c is natural log 3. Natural log y is equal to x squared plus natural log 3. Lockstep, that's the answer. No, you need to solve for y. This is the very last step. So like if this was the AP exam, usually this problem is on the free response, it's worth 5 points. If you did all this work, you just got yourself 4 out of 5 points. Now we need the last point. We need to solve for y. How do I get rid of ln? You e both sides. E to the natural log y is y. And then e to the x squared plus natural log 3. Now, what if you left your answer like that?
Wrong.
No, it's not wrong, it's correct. However, they are going to take off -1 because you didn't simplify your answer. That is the correct answer, it's just not simplified. So what you have to do is you have to simplify it to this. 3e to the x squared.
Because Ellen.
What was the LN3?
Yeah, but Mr. Park, shouldn't it be 3 plus e to the x squared? No. We talked about this before. Isn't this the same thing as e to the x squared times e to the natural log 3?
Yeah.
Because when you multiply, you add the exponents.
Yeah.
And what is e to the natural log banana?
Banana.
Banana. You have to do that on the AP exam. Anyway, if it's on a multiple choice, you're going to do all this work. Hey, I'm the man. But then you're going to look at the 4 choices. This is one of them. You know what they're going to do? They're going to have like this. They have all kinds of choices over there. So if you don't know what's going on, a lot of people are going to pick this one. Wrong. So you got to know how to work with logarithms and exponentials. That's why we study them in pre-calculus. Right? Why do we study exponentials and logarithms? Just so teachers have jobs? Okay, one more example and we're done. In fact, you know what? Why don't we just do one of the homework ones? Because you're going to ask me tomorrow anyway, right? Especially if it's even. That's shameless. Okay, let me look at these 2 that easy. 4, hey, that looks, yeah, I just did that one. I did not, I had no idea. 6, child's play. 8, okay, let's do 8. Because I know already, you guys are just gonna look at it and go, I'm just gonna write it on the board tomorrow. Why even bother? I know you. Initial condition, y equals 2 when x equals 0. Okay, here we go. Okay, here's the hardest part of the whole problem. I see x's and y's on this side, so I need to separate the variables. No, you can't ln both sides. Because you need.
Oh, separate.
Separate.
You have to separate how.
Divide.
E to the x over e to the y.
Okay, there you go, Bailey had it.
Yay.
Yeah,
Isn't this the same thing as e to the x times e to the negative y? Because you gotta add the exponents?
Yeah.
Now you can separate the variables, I think. Maybe not. If I bring this on this side, you gotta divide it. So what do I have here? E to the y, right? Because it's like 1 over e to the negative y. And then what happens when I put it on this side? Isn't that just this?
They're the same.
What?
They're the same.
No, one has x, one has y. They're not the same. They're not. No, it's not the same. It's not the same. Does everybody can get here?
Yes.
How many of you would actually think of this? That's what I thought. That's why we're doing it. Don't worry. No, you need to worry. You need to worry. Okay, what's the next step? Integrate both sides. Okay, so these are easy. E to the y plus c equal e to the x plus c. Mush the two c's together into just one c right there. Now what do I do?
Plug in the initial.
Yeah, plug in the initial conditions to figure out c. So if I plug in 2 for y and 0 for x, what is e to the 0? 1 plus c. We just figured out c is e squared minus 1. So this is what I got. This is what I got. E to the y equal e to the x plus e squared minus 1. Now I need to solve for y. How do you get rid of an e? You natural log both sides. But remember, when you natural log, you got to natural log the whole side now. So natural log of e to the y is y, right? Natural log of e to the x plus e squared minus 1. Right? You got to natural log the whole side now. You can't just natural. So what about this? Can I distribute the natural log? Should I distribute?
No.
Very good. You cannot.
Use
If you distribute, you just lost like 2 out of 5 points right there. All the good you did, erased. This is your answer. When did we ever learn to distribute natural log? Your pre-calculus teacher taught you this. When you see this, just distribute natural log. Who even teaches that? Just like cosine. When you see cosine a plus b, just distribute the cosine. Yeah. When you see a plus b cubed, just distribute the cube. No, and no. But look, I've been teaching calculus for 30-something years here, and I've seen it all. Students do this, even though they had algebra 2 and pre-calculus. Okay, so since we're going to spend 2 nights on this, we're kind of done. Okay, so you only have 10 problems for tonight's homework. You know what I would do since we got 15 minutes left?
Game.
No, I was going to say, I'm going to just do as many as I can right now.
But do Monday.
Wait, Mr. Hart,
Huh?
can you explain why it's like times and then x times negative y and then positive?
Because when you, okay, let's go back to algebra 1. X to the a times x to the b is x to the a plus b, right? See?
No, the other part, how come negative y becomes positive is 1y?
Because look, when you bring it on this side, you gotta divide it, right? So what is dy over e to the negative y?
Oh, easier.
Just e to the y, right?
Yeah.
Okay, to get rid of this, you have to divide it on this side, right?
Yeah.
So it's like this. But if it's a negative exponent in the denominator, that means it's a positive exponent in the numerator, right?
Yeah.
See, again, what's the hardest part of calculus? Algebra. It always is. Why are we playing games?
John
Go.
Travolta. What is this?
Do I have to, did I tell you about Cole Among last year?
No.
What happened with him in the first quarter playing games? He couldn't even bring his iPad into his room for the rest of the year. I don't want to mention names, Cole Among. Arizona State. Okay, let's try and use our time wisely.